Hello and welcome back to Let's Code Physics. We have had a lot of success with our projectile motion simulator, but we've been a bit limited in the scenarios that we can consider because our only condition for stopping the projectile is when it reaches y equals 0. And so the only scenario we've been investigating is where the projectile launches and lands at 0. We could have it start out higher or lower and have it reach 0, but there might be more interesting things we want to try out. We might want to try to see launching a projectile up a flight of stairs, for example, and there we would have several different possible stopping elevations. And we can't have that simply by adjusting to the bottom of the staircase and shooting up toward 0. So what I'd like to spend today's video doing is making it a bit more versatile in terms of how we can get the projectile to stop. So I've gone ahead and started a class here. I always have to look up how to set up a class because I'm a physicist, not a Python expert. The way a class works, it basically says I want to define a type of object. And so I'm calling this type of object stop block because it is a block at which the projectile needs to stop. I hope that's intuitive enough of a name for everybody. So let's see. So the first thing we have to do when we create a class is we have to define this init subroutine with 2 underscores on either side. I'm not sure where that convention came from, but it's just one of the things I have to look up every time. And so for a stop block, we need to know its position. We need to know where it's located, and we need to know its size. We need to know how big it is. So the first thing we need to do is create the visual. So we're going to create a box here, and we're going to call that self.object, just because you always want to be able to recall your visuals. So I just call it self.object in here. In order to create a box, I need to give it a position, and that's going to be self.position. And I need to give it a size. Actually, I need to tell it position equals that. There we go. And I need to give it a size. We're going to say size equals position dot size. I think I have that set up correctly. I'm going to cheat and refer to my drew to circuit video here for my wires. Let's see here. Size equals size, position. Oh, and I need to think about its color and its opacity. So let's see. Our color on the last one on the rulers is white. So I guess we need something else. So let's have that be green. Excuse me, not size, color. Let's have its color be green, just because this is supposed to represent the ground. I suppose it means I could represent it as brown, but I'd rather this be grassy blocks rather than just dirt blocks. Grassy dirt blocks, I guess is the technical term. And then opacity, let's leave that at 1 for right now. We might want to make it translucent later, but I'm not sure. We'll leave it that way for right now. And so this is going to allow me to create that visual. So what I've done here is I've added, I've started a list of stops. So I need to be able to tell where those stops are later. And so we're adding a stop block at position 440. So the position vector, I think we talked about this before, that's the center of the object. So you want to think about where you want the center of the object to be. So if I want the bottom of the object to be at y equals 0, then I need for my center to be that far above, to be far enough above 0 in order to make this one go down to 0. So if this has a size y component of 8, then it's going to go downward 4 from the center. So if I put it up 4, then it will go down to 0. Let me show you what I mean there. And I have a problem there. Oh yeah, I need to, excuse me, I tried putting something in ahead of time, and let's just comment that out and recall it later. Oh, and of course I messed something up there. What did I do? Oh, whoops, why do I have that called position.size? That should be self.size. My bad. I think I was in too much of a copying mode. Okay, so you see here, we're at, this thing is 8 units tall, so it's taller than our y-axis is here, and we are at 1, 2, 3, 4 in the x, and so it being centered at y equals 4 means it's going to go downward half of 8, and that is 4, and so that gets us down to 0. Now you notice I don't have the projectile colliding off of the stop block yet. That's because we haven't added that condition yet. That's the part that I had to comment out. I made a note to myself that that's where I need to add that. So let's see here. So the next thing I need to do, in order to figure out whether the projectile has collided with the stopping block, is I need to know where the edges are on this thing. And so again, I'm going to steal some code from my Druda circuit here. Basically, I need to be able to tell where the top, bottom, right, left, front, and back edges are. I'm going to go ahead and add the Z. Even though we're not working in the Z direction yet, I'm going to go ahead and add that just for when we do want to work in 3D in another couple of videos or so. And so the way this works is I need to be able to tell where the top of the object is, where the bottom is, where the right is, where the left is. I need to be able to tell where the edges are, because that's where I have to look for a collision with the projectile. And so I've got my position here, and I don't need this self.object.size. I can just reference the size itself. And so basically what you do is you go to the position. You start out at the position here. Remember, the position is in the center of the object, and then you go out half of the size. So if I want to find the top, I need to start in the center in the y direction, so I need to start at y equals 4 in this case, and then I need to go up half of the size in the y direction. That's going to be half of 8 gives me 4, 4 plus 4 gives me 8. That might seem trivial in this case, but that's because we're starting at 0. If you think about the the x direction, x is starting at 4. So to find the right side, I would need to start at 4 and then add half of the size's x component. So the size's x component is 0.1. So I would be going to 4 plus half of 0.1. So I'd end up at 4.05. And then if I wanted to find the left side, I would take 4 minus half of 0.1. So I'd be at 3.95. And again, this is all just so that I can check for a collision with the projectile. So let's scroll down and let's start working on that condition. Basically, whenever the projectile collides with a stop block, I want it to stop. Right? That's the whole point of it being a stop block. So here we've got our loop. So previously I just said while the projectile is greater than, or the projectile's y position is greater than or equal to 0. Now I've traded that out for a Boolean variable, keep going. So keep going is going to start out as true, and while we keep going, then we're going to keep going. And so keep going is going to turn to false if projectile.pos.y is ever less than 0. So once it passes the ground. And I also want it to turn false if I collide with, or if the projectile collides with a stop block. So the way I can do that is I can search through the stop blocks in the list. I currently just have the one, but you can imagine a scenario in which I have more of them, like that staircase example earlier. So let's do this. So let's say, I think it's for each. No, it's just 4. For each is C#. So we're going to look at 4 block in stop, what is it? Stop list? I've already forgotten what I called it. List of stops. That makes more sense. List of stops. So in other words, it's going to go through every item, every object in the list of stops, and it's going to temporarily store the one it's looking at in the variable block. And so what I can do now is I can look for whether we have a collision. So, for example, let's suppose we want to detect a collision with the left edge. For it to have a collision with the left edge, I would need to first check whether it's touching the left edge. So this is going to be, let's see, we're going to check for if, we want to check for if the left, block.left, right? So I have an attribute called left, and so that's going to be, it's the x coordinate for left there. Awesome. Is, let's see, all right, so if I want to check for collision with the left edge, then I want to check for whether the edge of the for whether the right edge of the projectile is touching that left edge. So I want to see if it's going just a little bit inward to the right. So I want to check for whether this is less than or equal to the right edge of the projectile. So let's think about that. So the projectile has a position in the x direction, and I'm going to be adding to that its radius. Where do I have that stored? That would just be projectile.radius. Awesome. So projectile.radius. Okay, so what we're doing here is we're checking for whether the left edge is at a lesser position, meaning it's to the left of the projectile's right edge. So we're kind of setting up the same calculation here with the projectile. Now that isn't the only condition we need to look at, because if the projectile has gone above or below the stop block, then I don't want it to stop. So now we need to check the y coordinates. So then we're going to also check for if the block's top position, so we're looking for the top edge, is, let's see here, I want that to be less than or equal to projectiles, I do want that to be greater than, to see if it's touching. So all this is to check to see whether it's touching. So the block's top position greater than projectile position dot y, again, plus projectile dot radius. Okay, so in other words, what I'm looking for here is whether it has grazed the top, basically. So let's see. Yep. And I need to check in that case for whether the bottom is less than or equal to the same thing. In other words, I need to check for whether this is between the top and the bottom. I could do this using ands, but then that gets it, going off the screen. I know that's difficult for y'all to read, so I'm going to try doing some nested if blocks. If that becomes more confusing, just let me know in the comments, and I will go back to the lengthy and statements. I suppose I could make my name shorter. Well, I mean, even if I shorten projectile to proj, it would still get pretty long. Okay, so here we're checking for whether it's between the top and the bottom. And then I also need to check for whether it's between the front and the... Oh, actually, you know what? I suppose I also need to check for a collision with the... Let's see. This is getting me inside the left edge. But I also need to check for whether it's within the right edge, don't I? So if block.right is greater than or equal to projectile.pos.x, and that needs to be a minus, doesn't it? Because that needs to be the left edge. Radius. There we go. Cool. Oh, and actually, I suppose then for the bottom, I didn't change that to bottom, my bad. This one also needs to be, the top needs to be a minus. It's always so confusing because the right gets a negative, the left gets a positive, because you're trying to check whether, you're trying to check whether any piece of the projectile is within the stop block. And then we'll go ahead and do the same thing with the, actually it occurs to me this is going to work for collision with any edge, I think. So I'm going to take out that hash mark there. And then we'll do the same thing with the front and the back. If block.front is greater than or equal to projectile.pos.z minus projectile.radius. So now I'm just kind of going based on the top and the bottom ones. So now if block.back is less than or equal to projectile.pos.z plus projectile.radius. So what this should be telling me is whether any piece is whether the projectile, any section of the projectile is within the stop block. And the only way to really tell is going to be to test it. I think I've got the logic set up here. So here we would say keep going equals false. And then we come out of the loop the massive nested if block there. Let's run this, see what we get. We should be getting some collisions now. Okay, I mean, not now, obviously, but once we start hitting this thing. Boom, yes. Boom, yes, good. Good, okay, let's keep going. We should maybe get a couple more, I think. This is exciting. So we're now getting it to collide on the left edge. So what I need to test next is a collision coming from the right. And actually, I suppose I also need to check collisions coming from the top and from the bottom as well. Nice. Do the complementary angles still match? They kind of don't on this one and this one. Okay. Okay, and the rest aren't going to collide because they're not going to make it that far. Okay, cool. So this, you imagine you're tossing a ball, and these are the ones that strike the wall on the other side of the room. Cool. Okay, so let's try changing our stop block location and size. So let's see. So there we were able to test the left edge. Let's try testing the top edge. So let's have this thing located at 0, 0, 0, and let's have it go out to the right. Let's see, let's have it go to the right by 3. So let's make this thing 6, and let's give it a height of let's say just a half, so that way it'll be just a little bit above ground level. Okay, we're sticking to the left, and we stick to the top. Okay, we don't quite stick to the top enough times for me to be really confident in it, so let's move it over to the X a bit. So let's move it over to the X by 2, and then I can make it wider by 4. There we go. So that way it'll have the same left edge. Or no, it won't. Okay, never mind then. That did not do what I thought it would. What did I do wrong there? Alright, let's try making this one 8 then. 5. Ah, there we go. That's what I wanted. Okay, so now... Okay, good. I'm getting multiple collisions with the top. And, oh, this is really what I wanted. This is another thing I wanted to check. I want to make sure that it can clear the top. So you notice it's able to go down below the top edge because it's not coming into contact with the other edges. So that's wonderful. And so these are clearing this barrier now. And so we should be able to get our projectiles over. So we'll get one more that makes it over, and then we'll get a couple more that strike the top and get stuck there. Yep. I should get another 1 or 2 that stop on the green. Cool. So one of the things you can do with this, for example, is let's say you want to get a projectile over a wall. Let's make a wall here, and let's see what range of angles gets the projectile over the wall. So let's make it centered at 0, 0, 0. Let's give it a size of... Let's see, how high are these things going? They're going 1, 2, 3, 4, 5, 6 on average. So let's give it a size of 12. That way it'll start at 0, it'll go up to 6. I'm fine with it going down below the y-axis. Oops, that did not work because I got my x's and my y's confused. Let's go with a 12 in here now. There we go. I should probably know my x from my y right now by now. Okay, cool. So we've got a wall going up this way. We'll just ignore the foundational part down below the ground there. And so most of these are sticking to the wall. They're not making it over. Are we going to get one over? Yes, we finally get one over. So if I remember, these go in increments of 5. So that's 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60. 65 degrees is the minimum. So 65 works. 70 works. 75 works. 80 does not. So you can think of it like you've got this narrow window of angles that you can use to get it over the wall. Now, of course, another option is to increase the velocity of the ball, but it's kind of more fun to change the angle. So that's some pretty good progress for today. What we're going to do next time is try looking at some different scenarios by having more than one stop block. So we'll have like a staircase. We'll try shooting the ball down into a pit. And what I'd ultimately like to do, and this will probably be another video from now, is test out making a field goal in American football, and then I'll also try making a soccer goal in the rest of the world football. And that'll be fun because then we'll have to do it 3D, because then you've got to consider the width of it, and we'll work in another angle. It'll be lots of fun. So thank you so much for watching. I will see you next time. Bye-bye.